Hey there, CG Math students, and welcome to Notes 4.7 Part 1. So I've written stuff here in red. I'll read it to you, but you need to copy it down. So to simplify an expression, combine like terms, use the order of operations and the properties of operations, such as the commutative, associative, to find equivalent or equal expressions that are simpler or smaller than the original expression. An expression is simplified when all the like terms are combined. So please make sure you've written down those words in those blanks. Now let's go over like terms. So it says like terms are terms that have the same variable and that are raised to the same powers. Constants can be like terms. So let's write this down up top. Like terms, some examples of them could be something like 5k and plus 3k, right? That would become 8k. Sorry. So you just combine the constants, 8k, to give you 8k, right? And keep the variable. Something as simple as like 4y plus y would also be like terms. That would give you something like 5. That would give you an answer of 5y. I got 5y because we remember we have an invisible coefficient of 1 right here. All right. I could even make it a little bit more complicated by putting something like 5x squared plus 2x squared. Right? Again, they have the same variable and the same exponent, and that would give us something like 7x squared. Right? However, something like 3x squared plus 2x, those are not like terms because this has an exponent of 2 and this has no exponent whatsoever. All right, so if we go down here, are 6y and 10y like terms? Yes, they have the same variable, y, and they are raised to the same power, 1, right? Or they have no exponent. Are 5k and 5 like terms? No, and you should write this down. They don't have the same variable. This has a k, whereas this constant simply has no variable attached to it. So sometimes we can use the commutative property to change the order of the terms with the same variables raised to the same power and constants. So for instance, instead of saying 3m plus 7 plus 2m plus 8, I can move these terms around using the commutative property and say 3m plus 2m plus 7 plus 8. And our like terms in this case are 3m and 2m. That gives us the 5m. And then also we have 7 and 8, which added together gives us 15. So this is a simplified expression in the end, right? We've taken this long expression, we've combined our like terms, and we've made 5n plus 15. That's your final answer, right? Note a subtraction sign. So if I'm moving this 10, I have to move the subtraction sign as well. So that's oftentimes why I say plus a negative, right? That way, if we change everything to addition, we can move it around with the sign. So again, the like terms in this case are 5d and 7d. That gives us 12d. And then we also have the constants of 38 and negative 10, which gives us 28. So let's go ahead and rewrite and simplify this expression. So first, let's put our variables next to each other. 4z plus 6z plus 9 plus 1. All right, the like terms are 4z and 6z. That gives us 10z. Plus the other like terms, the constants of 9 and 1. That gives us 10. 10z plus 10. That's it. It's not 20z because this does not have a z attached to it. All right, let's do another one. 12 plus 12k plus 13. So we've got 12k plus 12 plus 13. So the only like terms are actually 12 and 13. 12k is not a like term with any of these because it has the variable k on it. So our answer happens to be 12k plus 13. Right? And that's our simplified expression. So notice 12k had no like terms. It was all by itself, so we just left it alone. Right? I'm going to have you do, I'll label this number 1 in Edpuzzle, number 2 in Edpuzzle, and number 3 in Edpuzzle. I'll help you out by reorganizing. So we have 9p plus negative 7p. I'm sorry, I forgot to say plus and negative to that. Plus 9 plus 3. You need to simplify that. You need to simplify 2b plus 15b plus 7 plus 16. And then you also need to simplify 8x plus x plus 10y plus 5. That is the end of part 1.